Hi, my name is Tracy Haxton. I'm a Technical Director at Wallingford Hydrosolutions. Today what we're going to cover is an introduction to FEH, the Flood Estimation Handbook. So what we're going to cover is what is it, what can you do with it, and how do you start. So first of all, what is it? Well, initially it refers to the Flood Estimation Handbook from 1999, but nowadays it really encompasses a full suite of methods for flood estimation within the UK. So the Flood Estimation Handbook is made up of supporting literature, datasets and software. So the supporting literature includes the initial 5 handbooks, but also additional supplementary reports and technical reports that have been written subsequently. The datasets include the FEH web service, where you can get the catchment descriptors, and the NRFA peak flow dataset, where AMAX and POT gauge data is supplied. The methods can be implemented in 2 main pieces of software. WinFAP applies the statistical method and FEH applies the rainfall runoff method. So why do we need flood estimates? Well, we need them for planning. Where can you build houses, for example? The design of flood defence schemes, analysis of individual extreme events such as those that occurred earlier this year, and also to maintain assets such as bridges. So why do we need models? Well, the return periods we're normally interested in are of the order of 100, 200 or 1,000 years, and the locations are normally small ungauged catchments. Whilst we have a very good network in the UK, there are still only 1,000 gauging stations, and most of these were put in the 60s and 70s, so about 50 or 60 years length. So therefore we need to extrapolate, and we need to extrapolate both to longer return periods and in most cases to also the ungauged site. To do both of these we can use either the statistical method or the rainfall runoff method. So as I've described before, there's 2 main methods, the statistical method and the rainfall runoff method. I'm going to very briefly describe each of these, but if you'd like further details, there are a number of presentations on our website. So the statistical method allows the user to estimate the peak flow for a given event. There are 2 main components, estimation of the index flood and estimation of the growth curve. So the index flood is the QMed, the median annual maximum flood. So if we had a series of AMAX data, as we can see here for the Lim at Putney, the QMed would be the median of that data set. By fitting an extreme value distribution to that data set, we can also derive a growth curve from which we can estimate the peak flow for a given return period. If the catchment is ungauged, then we can estimate the QMed from catchment descriptors, and we can estimate the growth curve from a pooling group of similar gauged catchments. The method can be implemented within the WinFAP software. The rainfall runoff method provides the user with a flood hydrograph, so not just the flood peak but the full hydrograph. It uses input rainfall to ultimately come up with the flood hydrograph. So the user inputs either design or observed rainfall. It runs through a loss model to produce the net rain. This is then routed using the unit hydrograph method to produce a direct runoff hydrograph. The base flow component can then be added and we end up with the flood hydrograph. If we have a gauged catchment, we can use the gauge data to calibrate model parameters, and if it's ungauged we can estimate those parameters from catchment descriptors. So this method can be implemented within the FEH software. So there are 2 main data sets, both are managed by UKCEH. So the FEH web service provides catchment and point descriptors. So these might include area, rainfall, slope, and also the design rainfall, such as the FEH 13 design rainfall. We can use these catchment descriptors to obtain the parameters for both the statistical and rainfall runoff methods. The NRFA peak flows dataset is an integral part of the statistical method and can be downloaded from the NRFA's website. So I always think it's useful to look at the timeline of the development of the flood estimation methods in the UK. This started back in 1975 with the issue of the first flood studies report. Over the next decade, a further 18 flood studies supplementary reports were published. In 1994 and 1995, the Institute of Hydrology published the reports 124 and 126. These were on flood estimation in small catchments and the development of the host dataset. In 1999, the Flood Estimation Handbook, as we know it now, was published. With the onset of desktop computing, they also produced the WinFAP and MicroFSR software products and the FEH CD-ROM. The rainfall runoff method was first updated in 2006 alongside the development of the FEH1 software, and the statistical method was updated in 2008. The FEH CD-ROM and WinFAP 3 were also updated to reflect this. In 2010, there was a project to update the design rainfall method, and this resulted in the development of the FH13 dataset. In 2015, the FH13 dataset was added to the FEH web service, which is an update to the FEH CD-ROM. And alongside this, the rainfall runoff method was also updated and released as FEH2 software. In 2016, following a project on how local data could be used in flood estimations, some of these findings were implemented within the WinFAP 4 software product. In 2018, there were some minor updates to the FEH2 methodology, resulting in the FEH 2.2 software. In 2019, following the development of BFI Host 19, which is an update to the IH126 method, the FEH web service was updated, and the FEH 2.3 model was also released as the FEH 2.3 software product. We anticipate that in 2020, following the findings of the small catchments research report, that some further updates will be made to WinFAP. So I hope that has been a useful introduction. Here are a few references that might help. So the top two refer to the FEH2 and WinFAP software, highlighting where the literature and technical documents can be found as well as the software. And the below two are links to the UKCH datasets, both the FEH web service and the NRFA peak flow dataset. Thank you.